The 2016 Astrocats are the first team to ever represent the University of Cincinnati in the NASA Student Launch Competition. This event is held annually at the Marshall Space Flight Center in Huntsville, Alabama, and hosts dozens of universities from all across the nation. The objective of this 8-month-long competition is to design and develop a high-powered rocket capable of delivering a scientific payload to an altitude of 1 mile and safely returning it back to the Earth. Our team consists of the team lead, Nick Fagan, rocket lead, Kevin Eliason, payload lead, Brandon Horn, safety officer and mission assurance, Aaron Deutsch, Andrew Offenberg, Caleb Wasmond, Justin Maloney, Cameron Crippa, Gabriel Puntale, and Jake Chesley. Here is a quick glance at our work breakdown structure, followed by our project budget. This is our project budget timeline. And this is our project network diagram. The critical path to project completion is shown here in red. Here we see a top-level view of our project schedule. Safety was the team's #1 priority at all times throughout the entirety of the competition. All team members were properly trained at the beginning of the year by our safety officer on topics such as hand and power tool safety, material safety data sheet locations, and hazard recognition and mitigation. To ensure safe assembly of the rocket, a safety briefing was given to the team before each task to make sure they were aware of all potential hazards. In-depth procedures and checklists were created to ensure the safe handling and installation of energetics, such as black powder ejection charges and rocket motors. All pop tests and flight tests were conducted at registered NAR launch sites under the supervision of the range safety officers. The team's safety officer ensured that the team always maintained the highest level of safety and followed all guidelines set forth by NASA, the Federal Aviation Administration, as well as the National Association of Rocketry. The team's first objective was to construct a subscale model of the launch vehicle and fly it in order to verify the design was stable. Using an accelerometer, we were able to obtain an estimated coefficient of drag of the subscale model. In addition to this, visual data was gathered to analyze and determine the flight characteristics of the design. Our full-scale launch vehicle was developed using the RockSim software. Once a stable design was selected, more advanced drawings of the launch vehicle were then created using Autodesk Inventor. The rocket was designed in conjunction with our payload to ensure everything would integrate properly. The shell of our fairing was made from layers of 4-ounce and 6-ounce fiberglass fabric and epoxy resin. The two pieces would join together with overlapping bulk plates and a shear pin running through the two of them. The fairing was then sealed with RTV silicone sealant to prevent air from leaking inside the chamber. The fairing would attach to the rocket using a custom coupler lathed on a machine from a solid cylinder of nylon. The mold for the fairing was made from a standard off-the-shelf plastic nose cone. By making a mold, the team was able to make multiple parts and test different manufacturing techniques to achieve the best design. Pop tests of the fairing were performed on the ground prior to being integrated into a final launch to ensure that it would open the way that we intended. By analyzing the altimeter, accelerometer, and visual data gathered during the flight, we verified that our design was stable. All components came back fully recoverable and no damage was done to the rocket. Our full-scale test launch proved that our fairing would stay intact during flight as well as deploy when it needed to. Our main payload was the Planetary Investigation Lander, or PIL for short. It is a probe equipped with a suite of electronics that gather information about the environment around it. It measures temperature, humidity, pressure, solar irradiance, and UV intensity. In addition to this, it also takes pictures and transmits its GPS location as well as all of the data back to our custom-made ground station. The payload structure was modeled using SolidWorks and Google Sketch. The structure was designed to handle the high shock loads encountered during deployment of the parachute. SolidWorks analysis tools were utilized to perform finite element analysis of the structure to ensure it would survive the shock load encountered during deployment. The structure had to be small enough to fit inside the fairing, but large enough to accommodate the myriad of electronics necessary to measure and transmit the atmospheric data, GPS location, and pictures. The ground control software was written in C++ using WX widgets at the GUI library. This integrated with a PC serial port provided through an Arduino, which allowed us to access the radios. Position data was transmitted from the PIL and the rocket tracking bay back to the ground control station. The ground control operator was capable of sending commands to both the PIL and the rocket tracking system. This was a major accomplishment for the team to be able to communicate with multiple payloads asynchronously and bidirectionally with no data loss. As part of the competition requirements, the team also had to perform educational outreach. The Astro Cats took to Winton Woods High School to perform water bottle rockets and teach kids about the concepts of thrust and drag. The students were first given a lecture on rocket stability and safety. They were then able to take this information to design and develop their very own rocket. We managed to reach over 350 students through our STEM-related activities. On the day of the competition, the Astro Cats worked diligently to make sure that all systems were go before proceeding to the launch pad. The rocket team prepared the launch vehicle for flight, while the payload team went through all of the system checks to make sure that everything was working properly. Once everything was fully integrated and checked out, we walked the rocket to the pad with the help of the NAR safety officers. Once everyone returned to the safe zone, the Astro Cats were cleared for launch.
5, 4, 3, 2, 1, ignition.
The rocket parachutes got entangled on the payload but still managed to land the rocket safely without damaging any of the components. Our payload managed to gather data through most of the flight, but unfortunately, due to a voltage regulator failure, it shut off right before deployment. We were unable to obtain any photos from outside of the fairing before the payload had descended to the ground. In the end, the Astro Cats had a very fun time competing in this competition and learned a lot from the experience. It allowed us to take all of the knowledge that we gathered throughout our college years and apply it to a real-world application. Our hope is that the school will continue this competition and next year's team will do even better than us by improving upon what we did during this 8-month competition. If you would like to see more of what we did in greater detail, please check out ucrocketry.com as well as our Astro Cats Facebook page.